Hello and welcome back. Let's continue to look at examples of derivatives of exponential functions. So here we've got a 5 to the 1/2 x, and again we can sort of break this down and think about it as a function that is 5 to the x. This is our outside function, is our exponential, and then the inside function is going to be 1/2 times the square root of x. So what we'll do is we'll just take the derivative of this guy using the chain rule. We'll take the derivative of the outside function. The derivative of 5x is 5 to the x times the natural log of 5. But with the chain rule, we plug back in our original function, so our original inside function. So we have 5 to the 1/2 square root of x times the natural log of 5. And we'll take all of this times the derivative of what's up top. This is going to be 1/2 square root of x. So let's finish this derivative. So we've got 5 to the 1/2 times the square root of x times the natural log of 5 times the derivative of this guy. And again, the derivative of a function times a constant, we can pull that constant out. So we just have the 1/2 floating around. And then we take the derivative of the square root of x. And again, the square root of x is x to the 1/2. So what I can do is I can just use the power rule. So I can bring down the 1/2 and I can raise it to the 1 less power. And there we go. There's our derivative. Let's simplify this. We have 5 to the 1/2 times the square root of x times the natural log of 5. I have 1/2 times a half, so it's going to be 1/4. And then what I might do is write this as 1/4. And then x to the negative 1/2, well, that's going to be putting x to the 1/2 on the bottom of the fraction. But what is x to the 1/2 but the square root of x? So there we go. Our simplified function, and I might even write this over one fraction. So here's our simplified derivative. Let's do one more involving these exponentials before we do something a little different. So we have the derivative of x squared, 2 to the x divided by 3 to the x. So here we have a quotient. We have the top divided by the bottom. So we're going to need to use our quotient rule. So the derivative of something of this fraction here, we're going to take the bottom and square it. We're going to take the bottom times the derivative of the top, and we're going to subtract the top times the derivative of the bottom. So when we have this, let's start simplifying this. So this is going to be 3 to the x times the derivative of 2 to the x. It's going to be 3 to the x times 2 to the x times the natural log of 2, because the derivative of 2 to the x is pretty straightforward. We just take 2 to the x times another natural log of 2. And then we're going to subtract 2 to the x times the derivative of 3 to the x. Oops. But the derivative of 3 to the x is just going to be 3 to the x times the natural log of 3. So again, pretty straightforward. And what I'm actually going to do is I'm going to leave this as 3 to the x quantity squared, because this will simplify in a little bit. So I don't want to square this out right away. So let's simplify this some more. I have a 3 to the x and a 2 to the x, and a 3 to the x and a 2 to the x. I can actually pull that out up top. So it's going to be 2 to the x times 3 to the x. And we have a natural log of 2 minus a natural log of 3 all over 3 to the x quantity squared. And then I can cancel out this from the top to the bottom. So I have a factor of 3 to the x and a factor of 3 to the x. So what I'm left with, and I'm going to write this in a slightly different way. So I have 2 to the x over 3 to the x times the natural log of 2 minus the natural log of 3. And here we have it. This simplified a lot, and what you'll notice is that it really does look like our original function, 2 to the x over 3 to the x. Our derivative is 2 to the x over 3 to the x times some number, whatever the natural log of 2 is minus the natural log of 3. So we use the quotient rule here, but I also want to point out that there is another way to do this. If you were to take 2 to the x divided by 3 to the x, well, we have an exponent on the bottom of a fraction, so this is the same thing as 2 to the x times 3 to the negative x. And here, we would be able to use the product rule, and it's maybe a little bit simpler why we would get this factor here when we end up taking some derivatives in there. So this is an alternative way. We could take the derivative of this using the product rule instead. The quotient rule seemed just fine in this situation. So one thing that is kind of useful to notice is that whenever we take the derivative of an exponential function, we get a natural log of a number. Well, there is one number that is really easy to take the natural log of, which is e. So if I take the derivative of e to the x, just like any other exponential, I'm going to get e to the x times the natural log of e. But the natural log is the log base e. So if I want to take the natural log of e, this is the log base e of e. And now the question is, e raised to what power is e? Well, that's just e to the first power. So this natural log of e, this is just the same thing as 1. So the derivative of e to the x is e to the x, which makes this a really nice function to take the derivative of. If we have to multiply by the natural log of e, and we're just multiplying by 1. So e to the x is an example of a function where if I take the derivative of that function, it's equal to the original function. There are more functions like this, but this is one of the nicest examples of a function who's equal to its own derivative. So let's take some derivatives and see this in action. So here we're going to take two derivatives. So we'll have to be a little bit careful here. So if I want to take the derivative of this guy, so let's just start by taking the derivative of this guy first. So let's take the derivative of x squared times e to the x. Well, I have a product. I have x squared times e to the x. So if I take the derivative of this guy, what I'm going to do is I'm going to take the derivative of x squared, and I'm going to take that times e to the x, and I'm going to add x squared times the derivative of e to the x. So I'll take the derivative of one times the other plus the derivative of the other one times the first. So here we can see that we're taking the derivative of the x squared in the first term, and over here we're taking the derivative of e to the x. So let's simplify this guy. The derivative of x squared is just 2x. Well, that's pretty straightforward. And then we've got x squared times the derivative of e to the x. And again, e to the x is one of these special functions that's equal to its own derivative. So nothing much is going to change there. Again, if I wanted to, I could write the derivative as e to the x times the natural log of e, but we know that the natural log of e is just 1, so why even write it down? And then here, I can pull out an e to the x, and I can simplify this just a little bit. And there you go. The derivative of x squared times e to the x is 2x plus x squared times e to the x. But we wanted the second derivative. So let's take one more derivative. So if I want to take the derivative of this guy, 2x plus x squared times e to the x, so derivative of the whole thing. Again, I'm going to take the derivative of the first guy times the second. So all that times e to the x, and then we're going to add it to the first guy times the derivative of the second. So, derivative of a polynomial, this is pretty straightforward. Derivative of 2x is going to be 2. The derivative of x squared is going to be 2x. And then we've got this e to the x floating around. And then over here, I've got 2x plus x squared times the derivative of e to the x. Well, derivative of e to the x is e to the x. And again, what I can do is I can pull an e to the x out. So maybe I'll write that out front. And then I have one factor of x squared. I've got 2x and 2x. That's going to add up to 4x. And then I've got 2 hanging around. And there you go. That's it. Here is our derivative. We've got derivative. Second derivative of x squared e to the x is x squared plus 4x plus 2 times e to the x. And I think I'll do one or two more quick examples in a video after this.